The friction in a hydraulic system generates a lot of heat, and we have to get rid of that heat because oil will break down if it gets too hot. In a small system, the walls of the tank will be enough to keep the oil cool just by dissipating the heat through the tank walls. But in larger systems, we need something like think about a radiator in a car. Oil will break down if it's too hot, and the maximum temperature we want to see in oil is 140 degrees Fahrenheit or 60 degrees Celsius. Now you can, or I should say the maintenance people in the shop can measure the temperature of the oil, but you can get a rough idea just by touching the pipes in the system, which is kind of handy. Also, it makes you look like you really know what you're doing. So if it is 140 degrees, which is the maximum temperature you want, you can touch the pipe, but you can't leave your hand on there more than a second because it's too hot. So that's like the upper limit. If you cannot touch the pipes, then that means your oil has gotten too hot and you need to shut things down and figure out what's happening. So it's common to have water coolers, and again, think radiator in a car as an example. Actually, I once saw a shop that was doing plastic injection molding that actually bought car radiators and used them as coolers. So anyway, in a formal cooler, the hot oil from the system, return oil, comes in one end of the cooler and flows out, and then cold water comes in the other end of the system and flows out. And there are all these tubes in here, and let's look at these. There are all these tubes in here to give you a lot of surface area, because you want that hot oil touching as much cold surface as possible to conduct that heat away. These tubes are often made of bronze, which is, as you know, is part copper, which is a good conductor of heat. They might often be piped with a check valve in them because you don't want high pressure building up in your radiator thing. That would be bad, so there'll be a check valve in here. You also often see air-cooled coolers, and here this is like the fan in a car radiator that blows air across the radiator. So a car radiator really has fluid and air. Here we're talking about either fluid or air. And in an air-cooled heat exchanger, there'll be heat fins, or you could call them cooling fins. And then a fan blows air across those fins. So the hot oil comes in, conduction, that is the oil touching the fins, releases some of the heat into the fins, and then convection, which is the fan blowing air across the fins, removes the heat and blows it away. In cold climates, you might have an opposite problem, especially when you first start up in the morning, and that is your oil might be too cold. And if it's too cold, it's too viscous, it's too sticky, and it won't flow properly. So in those situations, you might have an actual heater. Now sometimes you can put a heater into your tank, like in the bottom of the reservoir, and it has an electric heating element, and that keeps the oil warm. Or you can use an ordinary heat exchanger, ordinary water-cooled radiator type heat exchanger to heat the fluid. Finally, here are the symbols. So they start with a diamond, and that might remind you of the filter symbol a little bit, but instead of a dashed line through the middle, they have a solid line, which is a mark of the cooling fluid and the hydraulic fluid being kept separate. Then, if the arrows are pointing out inside the diamond, that means heat is being carried away, heat is being carried out. So that's both the top symbol and the middle symbol are coolers. The arrows are pointing out away from the thing, showing heat is being carried away. If the heat is being carried away by air, then those arrows are open, they're not filled in. And we will see that later this term when we talk about pneumatics. You will see some symbols where the symbols are not filled in, they're open, and that represents air. If these arrows are filled in solid, then that means the fluid is a liquid. So those are both coolers, heat getting carried away. The one at the bottom is heat getting put in. So this is the symbol for a heater, and you can see it looks similar to a cooler. The difference is arrows are pointing in, showing heat is being brought into the thing. So there you go.